Hello, in this video we are going to be working with dosage calculations. So before we even do any calculations, we want to talk about rounding our answers and why. So when we are calculating an amount that is under 1 ml, we can put that amount into the 1 ml syringe, and the 1 ml syringe is marked off in hundredths. So for example, when I look at the 0.2 right here, and I look at the 0.3 right here, there are 10 little lines in between them. So I am able to accurately measure things like 0.21, 0.22, etc. So 0.21 would be right here, and that is to the hundredth place. So anything under 1 ml, you're going to round it off to hundredths because you can measure that very precisely. When we get over 1 ml, and then we're going to have to round it to tenths. So when I look at this syringe here at the half, which would be 0.5, and here's the 1, well, there's only lines in between there for things counting in tenths. So this next line is 0.6. And then we see 0.7, 0.8, 0.9, up to 1.0. So we cannot have additional precision to the hundredths like we can under 1 ml, so we're going to round to tenths. So we want to memorize those rounding rules for now, and then as we get into practice and we always have a syringe in front of us, we will just round to match that syringe. So we'll always be filling our syringe exactly to one of the calibration lines, and that means that we'll be rounding to hundredths under 1 ml, tenths over 1 ml. When we're rounding with pills, it first off hardly ever happens, but if it does, we need to round to a feasible dose. So depending on the pill or tablet, some of them need to be given as a whole pill, others can be broken in half, some of them can even be broken into quarters. And so it will depend on the medication, how precise we can be, but we will really find there are different strengths of pills so that we can give the correct dose without having to round. So our next thing to look at is why do we have to do math with our med orders? And we will find that dosages are going to be prescribed by their weight, so something like milligrams, micrograms, or grams, which is technically their mass, the amount of medication. But as the nurse, we're going to administer either pills or milliliters, and so we're going to need to convert that amount of medication to something that is measurable. So we'll look at the first example here. So we have an order for acetaminophen, 500 milligrams every 4 hours as needed for pain, and we have 2 different containers containing acetaminophen. And I'll notice on this first container that there are 500 milligrams in each tablet. So this container, I would give the patient 1 tablet, and they would have exactly the 500 milligrams that are ordered. And then I look at the second container, and this one tells me that it's 325 milligrams per each caplet. And so if I gave 1 caplet, that would equal 325 milligrams, which is not 500. And so this would be less of the pain med than the patient needed. And so that is why the original order is in the milligrams, so that we're giving them the correct amount of medication. If they had just said, give them 1 Tylenol, there would be a variety of amounts of medication that the patient might receive based on whether that 1 Tylenol was this generic acetaminophen with 500 or whether it was the brand name with 325 milligrams. And so to get the right amount, we order the med by the amount. Let's take a look at a liquid example. So for this one, I have amoxicillin, which is used to treat things like earache. It's an antibiotic. And so giving the right amount is super important because we need to kill the bacteria. And if we give the wrong amount, we give the bacteria a chance to mutate and become antibiotic resistant. So we see here that the order is for 800 milligrams. I'm looking at the first med. I see the strength here in the middle, and I can do this math in my head and see that I would give 10 milliliters. because it tells me 400 milligrams is 5 milliliters, so 400 times 2 would be 800 milligrams, would be 10 milliliters. However, if I gave 10 milliliters of the second concentration, that would only be 500 milligrams because the strength of the second one is 250 milligrams per 5 milliliters. So if I gave 10, I would double that. So 5 times 2 is 10, and that would give 500, which is not the 800 that's ordered. And so again, we have an example of why the order has to be in milligrams instead of milliliters. But as a nurse, I don't have the ability to measure the milligrams. And so I have to do some math to convert it over to milliliters. So let's take a look at some examples and some ways to set up that math to do that conversion. So here I have an order for 7,000 units of heparin, and I'm asked how many milliliters. So first I need to identify on the label what is the concentration or the strength. And so I see that here in the middle, that this med has 10,000 units to every milliliter. So I can see just in my head that with an order of 7,000 units, a strength of 10,000, I'm going to give less than 1 milliliter. To set up the exact math, I prefer dimensional analysis, but in your pre-lecture video, I also showed you a nursing formula strategy and a proportion strategy. So in the dimensional analysis, we always start with the order, and it's one of the reasons why I like this method, because it's very natural to start with the order. We know dimensional analysis requires fractions, so I put that over 1 as a placeholder. As problems get more complicated, there may be a timing in the denominator, but for this first problem, the timing is not mentioned, so I just have the placeholder 1. I know that in dimensional analysis, I have to set up the problem to cancel units. So looking at my label, I see that there are 10,000 units to 1 ml. So I am taking what was a fraction on the label and setting it up that the labels cancel. And so my math here would be 7,000 over 10,000. And with the help of a calculator, or you might be able to do mental math on that one, but for most of us, help of a calculator, I see that that equals 0.7 milliliters. No rounding required. It came out to a number that's easily measurable. All right, let's do another example. So take a look at the next one. In this problem, it says the doctor ordered 3,500 micrograms. So that's the order. That's where I'm going to start my problem. Even before I look at the label, I'm going to set this up, micrograms over 1. Then I need to find the strength to figure out the milliliters. And so the strength, very obvious here, 5 milligrams per 5 ml. So when I went to set this up, I realized that milligrams does not match the order. The order was in micrograms. And so milligrams and micrograms are not going to immediately cancel. So this is where I can use my metric line. So I'm taking my 3,500. I'm thinking King Henry died by drinking chocolate milk full of microorganisms. This was micro. I want milli. So 1, 2, 3 moves. So taking my decimal, 1, 2, 3 moves. So now this is equal to 3.5 milligrams. Put that over 1. And then I can use the strength, setting up my dimensional analysis. 5 milligrams is canceling in the denominator, 5 milliliters in the numerator, and I do my math. So I multiply straight across and then divide by 5, and my answer comes out to be 3.5 milliliters. Now I do want to show you that you can do this without using King Henry. So if you prefer, you can start with the 3,500 micrograms, put it over 1. And then you can use from off of your pre-lecture notes that there are 1,000 micrograms to 1 milligram. So setting that up to cancel the micrograms, and then using the strength with the 5 milligrams to 5 milliliters, canceling the milligrams, and you do all of that math, and it turns out that you have the exact same answer of 3.5 milliliters. So if you're not real comfortable using the King Henry, you can use the memorized conversions and set that all up within the dimensional analysis, which again is one of the reasons why I really suggest that you learn and go with the dimensional analysis. It's the strongest of our strategies. So even though the nursing formula is a nice shortcut, it's not going to work for everything. So we're going to stop here. We'll look at some more examples in our next video.